Hello everyone, welcome to Leetcode Daily Challenge. The problem that we are going to discuss today is minimum number of domino rotations required to make an equal row. So let's look at the problem description. So in a row of dominoes, you will be having two rows. So each column from these two rows represents a tile. So a tile can have two values. So the values can be from 1 to 6. So you will be having two rows with the values filled from 1 to 6. We need to we need to make one of these rows, one or both these rows with uh, equal values. So let's say we have row A and row B. So we need to make one of row A or row B with values, with all the values either equal to 1 or equal to 2 or 3 or 4 or 5 or 6. So we can do rotations on the tiles. So the tiles can be rotated so that the values in row A and row B in a particular column can be swapped. So we need to find the minimum number of rotations required to make one such row. So wherein the values are the values are all equal in that row. So let's look at the examples. So we have two rows A and B. So we have 2 1 2 4 2 2 5 2 6 2 3 2. So this is the first example where we have 2 in the first column in row A and third column, fifth and sixth column. So second and fourth column, if you make 2, then all the values in row A becomes 2. So but we need to have a 2 in the row B in the same column. So if you see, we have 2 in row B in second column and fourth column. So if you do two rotations, that means if you rotate tile 2 and tile 4, we can make all the values in row A equal to 2. So the number of rotations required are 2. Similarly, the second example, we have 3 5 1 2 3 3 6 3 3 4. So here uh, in the second example, if you see second column, we have 5 and 6. That means we don't have 3. So we can't make all the values 3 in this. So we have to return -1. So the constraints are the length of rows can be from 2 to 2 star 10 power 4. So this is a huge input. So we need to do it optimally. And the values for a given cell or given column are 1 to 6. So let's check in detail an example. So let's say we have row A and row B. So we have 2 5 2 4 3 2 6 and 3 2 4 2 2 1 2. So the size of each row is 7. That means we need at least, if you see, number of 2's are more here. So it is maybe we need to we should try to make all the values in row A or row B as 2. So because the size of the row here is 7, we need at least 7 values equal to 2. So if you check, the number of values equal to 2 are 1 2 3 in the first row, 1 2 3 4 4 in the second row. So total 7 values. So there is a possibility that we can have a row with all values 2, but we need to find the minimum number of rotations. So if you see, the row B has 4 2's, whereas row A has 3 2's. So it is better we make all the values in row B as 2. So in the first column, if you rotate, we can have we can swap the values 3 and 2. So that will be one rotation. Then in the third column, if you rotate, we can have one more 2 in row B. And in the sixth column, we can have one more 2. So that makes all values in the row B as 2. So we need 3 rotations. So a few more cases that we need to take care. So let's look at 2 more examples to get a better understanding. So here we have total number of 1 2 3 4 5 6 7 8 2's. But the size of the row is 6. So we have 8 2 values. So ideally we should be able to make a row with 6 2 values. But if you see closely, the fourth column has 4 and 5 values. That means there is no 2. So we can't make that column equal to 2. So here it will be a -1. So even though we have more number of 2's, we cannot make fourth column as 2. So we should check every column. That means every column should have that value either in row A or row B. So let's see one more example. So here we have the size of row is 6 and we have 6 2's and 6 5's. So here we have multiple values which can be made equal to a particular row. So we don't have to take care of multiple values. So if you take one value and check if it can fill a complete row, then that should be fine. So let's look at the source code, how to handle. So we have a vector of values for row A and row B. So first we need to count each value. So how frequency of each value. So how many times number 1 is coming, how many times 2 is coming, how many times 3 and so on, how many times 6 is coming. So first we count. So we take till size of row. So we count values of so A of I will be either 1 to 6 and B of I will be 1 to 6. So we count all those values. So to make a valid row with all the with equal values, we should have at least one value which is more than the size of the row. So that we need to validate in the second for loop here. So first we will initialize valid equal to false. So and we also need to find the time number, whether it is 1 or 2 or 3 or 4 or 5 or 6. So we check all the values 1 to 6. If any value is greater than or equal to error size, then we find valid value. Then we note down the tile number. So it can be 1 to 6. Then break. So we if we can't find a valid value, then we return -1. So if we have a valid value, then we need to find the minimum number of rotations. So for this, we need to check at every index whether we have this tile value or not. So one of those in every column, either in row A or row B, we should have that particular tile number value. So if A of I not equal to tile number and B of I not equal to tile number, that means both the values are not equal to our required number. That means we can't make a row with equal values, so we return -1. If A of I is not equal to tile number, then we count how many rotations we need to perform on row A. If B of I is not equal to tile number, then we count how many rotations we need to perform on row B. So because we count both the rows, because we don't know which is the minimum, so we count the rotations of both row A and row B, then finally we return minimum of rotation A and rotation B. So this way we get our minimum value. So we finally return minimum of rotation A and rotation B. That should be our answer. So let's execute and see. So I have created a few examples. So 2 minus 1 1, 2 minus 1 1. So it's perfect. So let's submit and check the runtime and memory. Yes, so solution has been accepted. Let's check the details. Okay, so all the test cases have been passed and runtime is 260 milliseconds. We have been processing both the rows once. So it is a O of n solution, and space wise it is a constant space. So we use only array of 6 values. So it's O of n, O of 1 space and O of n time complexity. Thanks for watching. Please do provide your feedback. Thank you.